in the humanities. Professor Pratim Sengupta is professor of learning sciences at the University of Calgary, where he has also served as research chair for STEM education at the Workland School of Education. His research advances critical and humanistic scholarship at the intersection of computational models of complexity and STEM education, and he does this both in the classroom and in public spaces. He's participated in collaborative computing installations, which have been installed and exhibited at the Museum of Modern Art in New York City, Canada's National Music Centre, the TELUS Spark Science Centre, the Banff Centre for Arts and Creativity, and many other places. He's recipient of an NSF Career Award, and he and Professor Shanahan, together with Dylan Paré, shared a Paul D. Fleck Award, which gave them a major residency in digital arts at the Banff Centre. Dr. Marie-Claire Shanahan is an associate professor of science in the Workland School of Education at the University of Calgary, where she has also served as research chair of science education. She studies identity, language, media, and gender, and their influence on participation and engagement with science by people of all ages. Professor Shanahan's research focuses on personal interactions between insiders and outsiders in science contexts. She examines student-teacher interactions and their impact on current student identity development, including motivation and interest in pursuing careers and further studies in science. And as I said earlier, she and Professor Sengupta with Dylan Paré shared a Paul D. Fleck Award. The work of Professor Shanahan and Professor Sengupta is really exciting because it's taking something we often think of as dry, objective, impersonal, which is computer modeling, and they connect it to the most human thing, which is a narrative. How do we connect computer models to people's stories and the meaning that those stories carry? So without further ado, Professor Sengupta, Professor Shanahan, it's such a pleasure to have you with us this afternoon.
Thank you, Jonathan, for the introduction. Marie-Claire, can you unmute yourself or good?
I'm all set now, thank you.
Okay, all right, so I'm gonna start by sharing my presentation. Share sound. And we'll go with that. All right. Oh, not the slide I want, but the slide I got. All right. Thank you, everyone, for being here. I know we are in the strangest of times, and we're all busy, and we're still here. And Jonathan and Elizabeth and Mary Gray, it's and Anand who's here, and so grateful to all of you for inviting us and making this happen, and it's just really exciting because we live inside the worlds that we're going to talk about, and these conversations give us an opportunity to actually look at the mirror in a very profound way, and we take these opportunities seriously, and hopefully that will come across. All right, I'm going to begin the talk, and we'll go from there. So the title is Public Computing, Flocking, Segregation, and Boundary Play, and that's literally what we're going to talk about. And public computing is a world that Marie-Claire and I created back in 2015, 2016, when I first moved to Calgary. And what we really were interested in is the intersection of design and publicness. And we are both scientists, and Marie-Claire is an engineer in addition to being a scientist. And we wanted to live at the intersection of design and publicness in STEM, with STEM. And so for us, computing, computational modeling, complex systems, and all of this exist at the intersection of these two sort of spaces. And so we, at the highest level, we just ask two basic questions. How can we design computational science as public experiences? And how can we center voices and experiences from the margins? And I want to highlight at the very beginning that the word voice here does not imply like literal voice. That is an ableist imaginary, but at the same time, what is not ableist and what is deeply restorative is the sense of unsilencing, the sense of seeing more, hearing more, listening, and also the sense of multivocality, that even within a word, the whole world can live. And then if we start to look at words and language and technique in that light, then what kinds of experiences can be centered, especially those experiences from the margins. And so the story that we will share are actually really a story of unfolding two classic algorithms. And by unfolding, I basically going to go back to the next slide, and I'm going to bring us back to this slide, and then we'll hand it over to Marie Claire. So this is an example of just 3 lines of code that define the shapes of voids and how these things get unfolded across different spaces. This is our student, Michael Cutler, who's actually trying to compose music to work with the algorithms here. This is me and Marie Claire trying to figure out how to make sounds work on projected screens. This is Dylan Perez's work. We'll talk about taking the algorithm and trying to see if we can actually understand resilience and marginalization as complex phenomena. This is an installation at the Science Center in Calgary. This is an installation at Canada's National Music Center. This is a 9-year-old child who's 9 or 10-year-old child who's actually doing amazing things with just hands and hanging out with us. So this is how code gets unfolded, and that's the story that we're going to tell. And we're going to tell this story with 2 algorithms. One is the flocking algorithm, and the other is the ethnocentrism and the segregation algorithm. And these are both several decades old, but they're very powerful. They've stood the test of time. Craig Reynolds, who I recently got to know in person, wrote this algorithm in 1987, and you have seen this work. This is the work that won him the first ever Academy Award for technological advances in cinema in 1998. The swarm of bats in Batman Returns, that was essentially an instantiation of this algorithm. The ethnocentrism and segregation models come out of Thomas Schelling's work. Actually, the work happens in 1960s. The book gets published in 1980. Thomas Schelling gets a Nobel in the 2000s. And then Hammond and Axelrod kind of take this on into political science, trying to model conflict resolution. And what this essentially, both these models essentially show is that phenomena such as flocking and segregation of similarly behaving people happen, or agents on the computer at least, they happen in an emergent fashion. They don't happen because they're pre-planned. And I will leave things there. And Marie Claire, the stage is yours.
You're muted.
I think I say in every meeting that I'm in at this point in the pandemic, I really should know, I really should be able to handle the mute button. But I do it pretty frequently. I did get distracted there for a moment thinking about Batman. My daughter loves Batman and asks me to do impressions of Batman just about every day. So I had a good laugh remembering there's actually part of our presentation that referred to Batman. I will spare you my, my version of Batman's voice. But that's really what we want to talk about today is these kinds of experiences where we're creating opportunities for who we are to be present in our computing experiences, rather than our computing experiences being something that is separate, distanced from, and seen as an addition to who we are, trying to make that central. Bringing ourselves into it. As Jonathan mentioned in my introduction, I really began my career looking at studying identities, and that really came from my experiences as a teacher, as a science teacher, and trying to understand the exclusionary forces that played out in my classroom, even when I didn't want them to. and felt like I was trying really hard to avoid them. And so that was really my interest in all of this, came from how are spaces exclusionary, even when the people that are creating them don't see them as exclusionary, and certainly don't necessarily intend them to be exclusionary, but that they are experienced in that way. And that conversations around that are how Pratim and I came to finding this place where the things that we both cared about came together in this question about how do we create public computing, and what can that really mean for participation in computing experiences. So as he mentioned, we're going to tell this story. We have multiple stories. We're going to tell the story primarily through two algorithms. And one of them is the flocking algorithm. That's our introduction to Greg Reynolds and to Batman and Gotham City. And this is, as he said, a really classic algorithm, and it's a really great example in terms of people experiencing the idea of how interactions that play out by kind of single agents create kind of bigger patterns that emerge from that, and that the patterns we see only come from decisions that the individual units make. And so the whole algorithm is built on kind of three parameters. You can see them down there: cohesion, separation, and alignment. And so there's nothing in the code here that tells the whole group what to do. Everything is just, the whole experience is just built on each one being told to kind of ask itself three questions. Figure one, you can see their cohesion. How close or how far away should I be from kind of the center of a nearby group? You can see there's kind of a radius of influence, and within that, where's the center of that group? That's everybody but me. And should I be trying to stay really close to it, or should I be trying to get away from that center? The second question is now not the center, but actual individuals. Like, you're in a crowd, how close, pre-COVID times versus current times, how close do you want to be to other individuals, even if you're all heading in the same direction? So what should that distance be? Am I trying to stay very far away from individuals, or am I trying to bring myself where I can be as close to the other individuals as possible? And then the other question is, how much should I line up my direction with others? So am I taking my direction very, very clearly and very strongly from everyone else around me, and we all kind of, as soon as I get close to others, we all head in the same direction? Or is that really a weak factor in the way that I move around? And just those three things, you can see the code for that above it and kind of the pictures explaining it below it. And Pratim's just going to play what that creates. So out of it, we get a group behavior. So from individual level questions and kind of imaginary thoughts, we get kind of a group behavior that we can observe and try to understand. And it's really close to, our Science Museum has a beautiful dynamic video of birds kind of flocking, and that memoration kind of process of birds all taking up each other's directions. You get something that really looks very much like that. So that's the first algorithm that we're going to talk about. And we have created three public computing spaces that highlight that. As we said, it's a really clear example, a very understandable example of how you can place yourself in the position of an individual and ask yourself those questions, and then see how that those individual questions create kind of group behavior. So we have in the main floor of our education building, we have a place called DigiPlay. And for a long time now, Pratim can fill in the actual start date, time's a bit blurry, 2020, 21 for everyone. But for several years now, we've had this open computing space there. And we try as much as possible, it is open to interactions from anyone who is in this space. It is not a completely public space because it is in a university building, but it is in a space that is open to anyone who is sort of walking through campus. So school visits come through here. There's the university daycare is right behind us. It's a building that people cut through to get from nursing to the daycare or to other places on campus. So it's as public as a space can be within a university campus, in that it's a building that's used as a thoroughfare for a lot of people, and it's in a very main area. And it's just open for people to interact with. They can interact with it in a lot of different ways. You'll see in the picture there's some slider type buttons. So you can interact with it by changing some of those questions, the answers to some of those questions. How close do I want to be? How much should I line up with others? Anybody can walk up to this and kind of slide those sliders around and change what's happening. On the far left, you'll see a keyboard. And again, anybody who's there there's a little button on the side, click it open, keyboard pops up, and through there's a place where they can actually access the code itself and make those changes numerically and kind of understand the ways that the algorithm is working and what the pieces of it are. So we try very much, there's 3 separate screens there, usually to have the same kind of basic idea, often just the flocking algorithm, but or a simulation based on that algorithm, presented in 3 different ways, and that can be interacted with in 3 different ways. A second one here is, sorry, just really briefly, they all kind of come from that same general principle. Over on the right, you'll see the hack the flock, which is really quite similar, but has the addition of physical manipulations, again, just to change the answers to those 3 questions. My daughter loves this one. And you can actually increase the values for cohesion, separation, or alignment by spinning the steering wheel. So you can increase it with a big slam across the steering wheel or decrease it. And you can see those values, and you can see what it does to the flocks. Pratim, go to the next one. So I wanted to tell our first story here. This is an example from when the exhibit at TeleSpark was first being built. So you can see on the right that there's where someone would sort of see the flocking boids, the little triangles that follow our directions and ask those questions of themselves. And on the left, the code that runs it. This, and can let you play it, this is this
big triangle to these little minnow triangles. We tried different speeds and how to keep them together far away and stuff like that.
Doing good.
Yeah, it's amazing.
What else did you change? What was the last thing you just changed?
We changed this text from boids to minnows. So scream to separate the minnows instead of boids.
So are you wanting us to call these minnows and not boids anymore?
Yeah, technically. This shape.
This shape should be minnows? Okay. Cool. Thank you.
Good job.
This is Mary. Mary was around 9 years old and saw this as an opportunity to create something that she wanted to interact with. So taking these triangles, and what she wanted to do was create an aquarium. And she sat around for, I think it was more than 2 hours, just asking questions. Could you do this? How could I do this? What are these? What are the things that we can change? And she happened to be there while the exhibit was being built. So she really had access to kind of the whole team and things being put together in real time, and the code was sitting open. And so she very quickly got the idea that changes in the code could create something new in this space. And this interaction really was something that started the whole process of what we've been looking at recently, is that just seemed to draw her in a way that was very different from typical exhibits at the Science Center, which have really low time engagement rate, not as a bad thing, but they're just built to, people move through and try things and they want to know what it does. And I have a Science Center membership. I take my daughter all the time and we press all the buttons and see what happens and learn lots of cool things. We usually don't sit at things for 2 hours. And that she was really drawn in to find out what's going on and how can I make this into something that I want. She really spent a lot of time trying to figure out how to change the shape and really engaging with understanding the geometry and how the code represented the geometry, how it could be changed to create something that she wanted. And you can kind of see they're like a squished, flat, very, 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 very long triangle. And they really do look like minnows. And it changed it into her aquarium. We can go to the next slide. And this is what we have since that experience, and really being amazed at the kind of interaction that this opportunity, where it invited her in. She could see the entrance points, the code, what could be changed because it was in the process of being built. This really pushed us in the direction of what's going on when people engage in computing in a way that is not presented to them in kind of segmented hierarchical stages of, you must learn this, you must learn that, then you learn this, then you learn that. That's not at all what happened here. It happened very conversationally. It happened driven by interest. And we wanted to try to understand what was really going on here. And that's led us to this conceptualization of kind of learning that we see happening in public computing spaces that we've called boundary play. Sort of taking on ideas from sort of Girin and boundary work, and this idea of all of our interactions create what we think of as computing or science. And every time we engage with it, we're kind of recreating those boundaries. But also takes in elements of figured worlds and how we create these spaces that we believe exist. And so what we're really seeing here is, or what we think we're seeing over the many opportunities we've had to explore this, is that we think that there is, and this comes from the figured worlds perspective, Dorothy Holland's, and originally from Vygotsky, but this idea of how important pivots are to bring us into a world. So in some of Vygotsky's sort of early writings about this, the analogy he uses is about kids and how a very simple toy made into a sword or a hat can be the thing that draws you into a play world. That the sort of pirate's world emerges around you, around a child, the moment they sort of pick up the stick and say, haha, my sword. And that we're kind of, Dorothy Hollands has taken it that that's kind of a thing that can also often kind of bring us into and help us establish a new, our place in a new figured world. And we think that there's an opportunity here for this idea of playful, taking those two things together, for playful entry and play within that boundary space of moving in and out of computing. So often we're talking about short-term, in the bigger sense, short-term interactions. Even, in a museum sense, 2 hours is a long time, but in a child's education, 2 hours is really a short-term interaction. And the things that they learn from teachers and parents exist on a very, very different scale. But that these short-term interactions can create opportunities that are very different from anything else they'd experience. And that what they're able to do by using a pivot, and here we've highlighted, oh yeah, I can't circle things, this is not my screen. We are, Pratim, if you could go back for a second, sorry. This code here that defines the shape of the void for Mary was a pivot. It was wanting to know how to do that, took her from being a kid standing at the museum asking a question to being someone creating a simulation who is living in the world of the simulation as well as living in our world of computing and what that meant. And what we see happening is that we can engage in new ways when we have a pivot that brings us into an imaginary world. And we take up as well Holland's idea that when we think about what these worlds are, is less about learning conventions and the right words. And we talk about that often in identity work, the right words to use in places, the right kinds of decisions to make. But with this kind of interaction, we see what she was also trying to say. When we create a figured world, it's less about the rules and more about who the characters are. And that what takes us from frames to figured worlds is who are the people that exist in this space. And our kind of idea of boundary play as an educational experience is this idea that code itself, pieces of code, can be a pivot that not only kind of allows us entry into the technical world of computing, but allows us to create ourselves as a character in that world, even in a short-term interaction, and that those experiences can be really powerful. You can go ahead now. So this is a second example of that. We don't have a video of this one, Pratim. This is just photos, isn't it? Yeah, okay. So these photos, same algorithm, same general kind of idea. Visitors are allowed to look at the code and then make changes to it, see what happens. This is an interaction we had in that public space within our education building, where an adult and two children were visiting kind of casually through that space. They were definitely the public kind of visitors here, not students, not sort of formal, didn't have a formal role in this space. And they ended up creating, if you take a look at the middle picture, this kind of, I'll call it a glob, not to take away from their conceptions of it, a glob of voids. So if we go next to this, we'll see kind of how this came about and what they did with it. So Rex and Sam are the two little, not really little, probably, again, about nine years old. And they were thrilled with the idea that they could actually change the code. That was like saying you could put chocolate sauce on everything. They just were minds blown. They ran across the room saying, really, really, really? So they were very excited by that possibility. It changed their perceptions of what you could do, I think, in an exhibit, what they were allowed to do in a kind of subversive way for them. And so what they did, they wanted to change the values in the code for cohesion, separation, and alignment to extremely high numbers. Adults like to do change it from 2 to 5. Children are like, please let me make it 1,000, 1,000,000. I want to put big, big, big numbers in and see what happens. So they changed them all to very high numbers. And what they got was this glob. If we go, sorry, Pratim, we just go, nope, the first, yeah, one, thank you. So they first try to explain to each other what these big numbers are going to mean, because they were working through their understanding of cohesion, separation, and alignment. So they have to come together, but they also have to move far away, and they were trying to navigate that tension between the high cohesion value and the high separation value. Mary, the adult woman with them, said, oh, look, they're bonking into each other. Then one of them starts adding more and more and more and more. That's one of the ways you can interact with it, is just click on it to add more. They can't escape. It looks like a glitch. I called it a glob. They called it a glitch. Next slide. Mary, look what you've done. They can't escape. I'm going to call them the swarm. Sam, I'm going to call them the prison. And they're having fun with these names for it, and trying to build an imaginary fictional world around what not only themselves as characters, they're almost novelists here they're the writers creating this space, but they're also creating the fictional world of what the voids are experiencing. If they are, in this case, they've made them people, not minnows. So Rex says, anyone who gets close to the prison gets sucked in. I guess they have to stay as close as possible, and they have to stay away as far as possible. The forces being closer are stronger. So just go to the last slide. And they end up taking this really far. So she asks them a bit more on the conceptual piece. I guess they're cohering. Is that what's happening? But the kids still want to stick with the fictionalization, the jail cell. So finally, mom picks up on that they want to talk about the jail and not the values. Jail cells. Do you think this model could be used to explain what would happen in overcrowding in prisons? And they both kind of light up. They're like, yeah. And so they've created this whole story around around what the Boyds are doing and thinking, but that also makes them characters. That makes them the authors and the creators in this space. And it's a very different kind of interaction than we think is possible in other kinds of computing environments. Can go next slide, Pratim. So this is really just bringing together what we have been conceptualizing as boundary play by watching what happens in these public computing spaces, and that we're really interested in the way this creates new opportunities for anyone, parents, children, visitors, sort of not typical participants in whatever that means, or people who are participating in a way that's different from how they normally would. Even I would count that here as well. That really changes the kind of interactions that anyone can have with these simulations. So we think that boundary play is really characterized by this space where you can talk about sort of canonical emergence, as well as bring in informal language. Again, that's that ability to make yourself a character. Somewhere else, you might be not able to talk about pieces of a computer simulation bonking or being a glitch or getting excited that it's like a prison. They even like changed their tone of voice to make it sound like a film preview in a world where Boyds stick together. That there's also this co-creation of multiple worlds. Even in that small example, that small transcript, we see multiple worlds. There are characters already in multiple ways. There's sort of sociological perspectives, there's their personal perspectives, there's them as sort of creative authors, as the perspectives of the Boyds living in a world. All of that is really entangled. And that's something that's really important. We've noticed this in all these situations. They also invite intergenerational interaction, that the complexity of these spaces was enhanced by sort of parent-child interaction, adult-child interaction, multiple children, and again, in different ways. It's not adult as teacher and child as learner, it's intergenerational exploration. And we think that those are some of the key things that are coming together as key factors in boundary play. Pratim, having taken more time than I probably should have, I will stop talking and hand it over to you.
All right. So I'm going to talk about the next story, segregation, and we'll see how far we can go in terms of time. But I want to start with the socio-political context that really, and this one is very close to me and some of my students because we live in the global north, but we are immigrants, and most of us are immigrants, except people who are really indigenous to these lands. And but it's sort of it's a history that we don't really bring to surface, and especially immigrants of color, they bear the brunt of just about everything. And there are people of color, and so there is the increasing diversity in global north, especially with immigrants of color, recent immigrants, as well as people who've been led into these lands through forced migration over the last several centuries. So there is a lot that's happened in these lands. But computational models. How do computational models actually represent these things? Or what are the experiences around models of these experiences also? So below is a map of city of Chicago divided by unemployment and race, and it's a ward-wise breakdown. And it's pretty stark, closer to downtown and farther away from downtown. Above is a map of Canada that just shows increasing diversity in terms of immigrants of color, progressively increasing diversity. And then the problem that we are trying to tackle right now is that sociopolitical issues are not just data and policies. They're actually complex affective experiences. Migration and segregation and race are interlinked and emotional experiences. We carry pain and humiliation and joy and suffering with these experiences. And what does it mean for models? And how do models do they even try to capture it? Or what are the realities that models make explicit? So here is Schelling's segregation model in a few different forms. The basic assumption is a neutral von Neumann neighborhood. Jonathan, Marie Claire, and I, we know this from our physics lives. This is sort of the architecture of any statistical mechanics model, or just about any statistical mechanical model. And so it works not only for human beings, or it works for objects and physical objects, but we have also made it work for human beings. And then there is the code, which acts on each little dot here, or line or cross here is a turtle, as in Seymour Papert's logo turtle. They're reincarnations of it, and they can talk to their neighbors based on this von Neumann neighborhood to your left, and they can look at if they're same or different than the neighbors, and then if they're same or different, they exchange. So what Schelling called the calculus of contingent decisions, interdependent decisions. So if they're the same kind and I'm an ethnocentric agent, I will offer them help. But if they're the different kind, I will take help from them, but won't help them if I'm ethnocentric. If I'm altruist, I will help everyone. If I'm an egoist, I will only help myself. And if I'm cosmopolitan, I will only help the other kind and not myself. And cosmopolitan agents in some algorithms are also known as traitorious agents. And the reason I'm mentioning this is not because I relish in the terminology, but because of the symbolic violence and of these terms, and we'll come to it. And so what we are going to talk about is this notion of transitional othering that we think is actually a fairly helpful approach to bring in account our experiences that are not actually just about the logic and the neutral descriptions. When we start talking about these simulations, our fundamental insight has been that the explanations are laden with affect and pain and uncertainty and thinking very carefully about, can I even talk about these things? And they talk about race, segregation, and migration, which are very difficult topics to bring up just about anywhere, but especially in the southern US. And I began this work in Nashville nearly a decade back with Andy Hostetler, who's still in Peabody. And transitional othering is this idea that I can project part of who I am onto this agent, similar to what Marie Claire is talking about, but with a little bit of distance. I'll talk about my experiences, but not exactly about my experiences, kind of my experiences. And that kind of distance goes a long way. And so what we found is that what really helps this mechanism of transitional othering, despite the problems with the code, is recontextualization. So now this particular simulation, this particular map that you're looking at is a one-dot map of race. It used to be known as a one-dot map of race back in the day. Now it's known as a racial dot map. It's work done at Johns Hopkins. And you can look it up. And it actually puts a dot of a particular color based on the self-declared ethnicity on the US Census. And I think it has data from 2008 all the way up until a couple of years back. And you can really see segregation in any urban area in the US. And this, I think, is Minneapolis, where you can actually see, like, right around downtown and close to universities, it's pretty diverse, different colored dots. As we move away from them, we get more homogeneous, really more homogeneous. And what we found was that in relating what's happening in the simulation to what they're seeing in the map, students are able to do that kind of transitional othering. They can both see themselves and the other. So here's an example. Here's a pre-service student, actually, many years back, who looks at the map and the simulation and starts talking about it's important for his students, future students, to have that experience so that they can look down on themselves, and not just to say I'm the blue dot, but also there are red dots and green dots, and so they can think about the stuff, and they're challenging themselves and thinking about it not just from the normal perspective, but yeah, it's not just about your house. It's about your house, find your house, but it's also not about your house. And you can see that little distance, the distance that enables this kind of othering to become voiced experiences of othering. And I want to contrast this with, this is Emma Lazarus. Give me a tired, you're poor, your huddled masses yearning to breathe free, the wretched refuse if you're teeming shore. You compare that with the models that economists and urban planners, the language that they use. It becomes a language of intentional acts, and we will critique that act later on. And so we can then flip this question to, can simulation help us understand people's feelings and emotional experiences related to race, segregation, and immigration? So we're flipping kind of transitional othering on its head. And here's an example from a paper that we are currently in the process, that is currently being reviewed at a journal. And you can see everyone, just about everyone who's worked on this particular project is a co-author here. And that's really how we work. And so here is an example where this is a facilitator who's an immigrant of color, and the visitor, Dennis, nicknamed Dennis, is a white Canadian, and they're talking about their experiences of interacting with the simulation, and they're trying to get a sense of why ethnocentric agents are dominating over time. And Dennis then is asking about the traitorious agent, the cosmopolitan agent, the agents that don't help their own kind, but they help others. And the facilitator is now talking about, let's say, and this is where they're kind of drawing kind of a bit of their own lived experiences. They don't cooperate their own kind. Let's say it sounds kind of racist. Let's say I'm a new immigrant and is not contacting with like his or her people or his or her background or countries of origin. And then, but always like Canadians, and then like trying to build a life with this strategy. And then Dennis is feeling bad and saying that, I wonder if that's kind of pressure to conform to the society to which you're immigrating to. Like if immigration is higher, maybe the pressure to become like them would go down, and maybe you kind of want to distinguish yourself from your origin kind of thing. So they're now trying to really understand this really painful process of giving up one's language, giving up one's culture, giving up one's dresses that they're used to wearing, clothes. And the facilitator now says, yeah, because we're like, as a newcomer, I can say we're expected to assimilate, right? Language is the first step, and then afterwards, there's all the cultural things coming with it as a package. There is no neutral logic here. What I hear is pain, and it was such an eye-opening moment for us. And this is someone from our team who's actually voicing this. And it took this simulation for this to be voiced. That's the value of the simulation. It's not the rules of Schelling that's so powerful that can model segregation, right? And Gopal Guru, a famous Dalit scholar in India, talks about migration as a moral resistance, a moral protest, that people who don't have anything are often landlocked, and they migrate because it's a moral obligation they have to the communities. They go and they bring back the tools that they were missing in their fight for oppression, because those tools also have been they've been deprived of these tools structurally. So when we see immigration and migration in that lens, all of a sudden these simulations become laden with love, fear, affect. And so that's kind of a big critique of intentional agents that we have. The neutral white gaze posits computational agents as intentional actors, but this would also mean that enslaved and colonized people would be cosmopolitans and humanitarians. And this is a dangerous fallacy, because the enslaved and colonized people do not have intentionality. So this is exactly what Bourdieu would talk about as symbolic violence. And this is, part of the work that's under review. I'm mindful of the time, and I had a whole bunch of stuff to mention in other related work, but I think I will get to it next talk. And where I want to end here is with a set of key insights that, we want generalized algorithms. Of course, algorithms by their very nature are generalized. I think that holds true for just about anything we do in the academy. We mostly build models, and we don't build bridges in the real world. We build models and bridges. And they require a lot of contextual support. And for the longest time, contextualization has been seen as an application. And I think in the book, Voicing Code, that just came out from MIT Press, we write about this, and we say that recontextualization is the experience of a symbolic abstraction is recontextualization. there is no such thing as an abstraction. The thing that lives on a device, that language that's edified in hardware or software, the moment there's a human being interacting with it, it is no longer on the device. And this is what I critique as device-centeredness, or technocentrism. You know, the answer to questions about technology should not be technology. The answer to questions about society should not be technology either. And the agents, then the computational agents, are both the self and the other, and we need to be mindful anytime we are designing interactions with simulations. And part of the othering that we can then begin to understand and include in our pedagogy are people's racialized emotions. And this is, I want everyone who's here to, after this talk, to go back, and after this talk, please read Eduardo Bonilla Silva's 2019 presidential lecture for the American Sociological Association. Please be changed by his words. We need to be changed by his words, and racialized emotions are fun, especially in the US and Canada. Every single interaction, there's a high chance that what we are operating on are based on racialized emotions. And it's a fundamental missing piece of any analysis in human sciences that we're doing. And then voice in code, I want us to see voice in code as the act of unsilencing the private language of pain and humiliation. And I think I will end here because we won't have time for conversations otherwise. And I'll get to the other stuff that I planned for next talk, where we actually pick up from here and we get into what we are calling now the moral horizons of conversations. Thank you.
Thank you very much, Pratim and Marie-Claire. That was a really fantastic talk. It's given me so many ideas, things that we can talk about. And so as we plan, we'll have a little conversation now, and then I'll invite members of the audience who probably have their own questions and thoughts. So I'd like to start by asking you to reflect on, I thought this was a really brilliant idea that you had of talking about boundary play, where Girin and people following Girin talk about boundary work as this very Trumpian approach to discipline, where you see that you're in a discipline, you're a scientist, there's public out there who's not a scientist, so you want to build a wall to keep the public out of science so you can keep the power to yourself. And this rhetorical trope that you make of turning the work of keeping others out into play that invites others to come in and let's play together, I think is very cool. And how much is the role of play and the rhetorical role of play in making that change? And what else is there in turning these boundaries that keep people apart to boundaries that you play by crossing?
I talked too much already. I think you should answer. They already heard me talk about play.
I think Marie-Claire, you should take this boundary. I think this shift from boundary work to play. I'll just say this, that every, words are like swords. We never know on which end of the sword we are. Either we are holding it for a while, but then eventually, it acts on us. And what I love about, and boundary play was Marie-Claire's very clear articulation in the work. And what I understood was exactly what you said, Jonathan, that it's unfolding. That's where, for me, the language I chose was unfolding, right? And the critique that I have formulated of, in general, I think there's a lot of ambient mediocrity in the field that talks about gamefulness and playfulness. And the idea is that if we gamify everything, we make it playful, and all of a sudden we can actually, engage with things. And I don't think boundary plays that. And with that, I will turn it over to Marie-Claire. So yeah.
Yeah, I think so. I think so too, because when we're talking about play, I think that, and we even mentioned this a little bit with Rex and Sam, is that it has also kind of play that we're talking about has the subversiveness, the rethinking things for the joy of turning them on their heads, that sort of childhood play really does, as opposed to that idea that play is gamification. If we just make a formal game out of it, it'll be play. But that it has meant that kind of play to us. And Gieren's work always, to me, has been, kind of comes from that idea of the failure to kind of solve the problem of how do we decide what science is. And so that we're, no matter what, we're always making a decision about what it is and who belongs in it and who belongs out of it. And I think that it only takes, and you're right, so much of that work, how do we keep changing these boundaries to decide who's out of it is usually more the question. And I think all that we're asking is, yeah, that subversion, turn it on its head. The unicorn is the driver. I have a 7-year-old, you can tell why unicorn's the first thing that came to me for play. But the unicorn does the housework, or the things that our children create, where it's funny just because it's absurd, but that the absurdity of turning boundary work, that the central question of boundary work becomes not who's out but who's in, is I think what we've been trying to do with that, not to make it sound too bigger than it is.
Thanks. And then to pivot over to the work on segregation and migration and the Schelling model, I'm very intrigued by this idea of the transitional othering, but there are things that worry me. And so you have a very persuasive account of how creating this sort of impersonal model then allows people to start to identify and empathize with the agents in the model and start to think about the pain. But I also worry, and in my teaching, this has made me very uncomfortable in teaching the Schelling model, is the Schelling model is really a way to tell a story about segregation where racism never comes into play. It's just people want to have a certain number of neighbors who are similar to them, and they're happy to have neighbors who are somebody else, and everything is coming from the bottom up, when in fact we know there was a very large national effort to deliberately segregate what were formerly even very integrated communities. And I worry that teaching this model can essentially deny that whole piece of history and kind of sanitize segregation. And you're working with this in a very different way. And I'd love to hear more of your reflections on coming from being very aware of those dangers of the Schelling model, and then instead using it to try to connect people with what the immigrant experience might be.
So, I think this is, literally the paper that I mentioned is under review, literally, that is exactly what the paper is about. And I bet Marie-Claire was also smiling as you were formulating that question, Jonathan. Literally, that is what we're talking about. We're trying to understand. I think so I have 3 parts to the answer. The first part is that every piece of code, every piece of technology, every word of theory that was made and is still made in the West will bring with it a certain kind of contrapuntal blindness. So Thomas Phillip and I have a paper published now in Journal of the Learning Sciences. If people are interested, search for contrapuntality, Pratim Sengupta and Thomas Phillip. It should take you there. Contrapuntality is a construct that we take from Edward Said, and Edward Said talks about contrapuntal realities as realities like so colonized lives far away who are invisible to us as enabling the privilege in the global north. And Said critiques classic literature as an emblem of that, like relying on contrapuntality. And then also thinking about, so any piece of technology built here will have a contrapuntal reality. That's dimension 1. dimension two, silencing white histories is not restorative justice. I think looking at white histories, if you look at the entire academy as white Brahminical histories, ableist white Brahminical histories, and also heteronormative, then I think those are the monuments that we have created. Those are monuments, and we've built them, so we should describe them as they are. I think that act of description is quite empowering. Being able to talk about Schelling's model with people who have been excluded from those models, I think is an act of empowerment. And of course, it's going to be jarring, but if we do it in solidarity, I think so. I see. So the big answer to the second dimension is that we dismantle. Part of the pedagogical work we need to do is dismantle these monuments that we have built, and we do that by working within technology, not doing mile-high critiques. So what worries me about the burgeoning field of algorithmic justice is that there are lots of critiques now about algorithmic justice. They're very essential, very, very essential. But what we need, I get worried when people like Timnit Gebru get fired from Google. I get worried when Melanie Mitchell gets fired from Google just because she was sorting through her own email to find evidence of wrongdoing by Google. Email that was supposed to be her property, and Lucy Suchman actually warns us about this way back when, that who owns emails, right? And this panopticon that any kind of technology will create. So we need to dismantle the monuments in technology, but we need to do that in solidarity. And if we want to do that, then we can't avoid learning about Schelling's work and really seeing that intentionality is not enough. Schelling came from a place, Schelling spent a long time as a White House advisor and tried to worked on really big problems like conflict resolution. And one could argue that he was seeking peace, right? So could there be a more noble desire? Probably not, right? But still, there are these blind spots. And why do we have these blind spots? I think then the third dimension actually begins from there. And I think that's where we didn't have time, but I've been moved by Anand's work, Anand Taneja, who's here, and completely moved by Anand's work on translation in the ruins of Delhi, where translation becomes an invitation to inhabit a new world, rather than and it's a beautiful way to think about symbols for me without giving in to the symbolic violence. So modes of translation that honor us rather than impose on us.
Thank you. I think that makes a good time for us. We're just about out of time, and I want to be respectful of everybody's time in these busy times. But perhaps if people who need to go can go, and Pratim and Marie-Claire, would you be willing to stick a little overtime in case anyone in the audience has some questions for you? We'll be happy to take some questions now. And I think if people will raise their hand on the Zoom channel, then I will just call on people who raise their hand. And you can either raise your, I think if you do the raise your hand thing in the participants box, that might be the simplest. Actually, let's see. It looks like, I'm not sure. It may be that right now that may have been disabled. Do people see the...
I see it in the reactions bar at the bottom.
Okay.
Everybody has that. But yeah.
Or people can just put into the chat window if you have a question, and I'll call on anybody.
Well, I'll jump in since I was really, really interested in the question of play and Marie-Claire, what you said about it's not about gamifying every learning experience. It's not as if we need to gamify everything to make the medicine go down, right? But I think the connection that I found most interesting was thinking about the work that's needed in understanding that kind of boundary play as a venture into otherness, right? Like that's entering into figured worlds and imagining figured worlds. In order for it to be fun, you know, for a child to put on the pirate hat, there has to be a way of thinking about, I am rupturing a boundary here. I'm rupturing a boundary between what I'm supposed to do and who I'm supposed to be and how I'm supposed to act. And then I really wanted to think about that in connection with what Pratim, you were saying about sort of this representational violence of hiding the physical pain of lived experience under, you know, supposedly value neutral metaphors. And that's one of the places where I really think when I'm teaching English, like I just really think it's really important to think about, like, when I'm teaching a class that this is the correct way to write, that I have to articulate the fact that I am doing violence to ways of speaking and being in the world, right? But at the same time, that's my job in the structure of the university that I'm in, right? I mean, any university. As an English instructor, yes, we're teaching critical thinking and interpreting and representation, but also I have to teach students how to write this language that does violence to them. And I'm trying to think of how I can make that experience more of an invitation to play, so that they are playing at that boundary and learning how to do that, but at the same time, not having it silence them. And also, Marie-Claire, I have to say, I never thought I would hear the name Vygotsky again after getting my education degree, so that was interesting. But I think, I don't know
Glad
if that's
to provide that experience for you.
Yeah. I don't know if that was a question or just a comment, but I wanted to say that I really appreciated the way that you were talking about learning and sort of playing at those boundaries.
I'll just jump in really quickly with something that in some ways we do. The only thing I'll say is that I think we struggle with the same question in relation to computing and computing norms. And I really come from a physical sciences education background, as a physics teacher. Struggle with creating this space where there's the playful invitation and trying to find ways that the appropriation and mastery of norms that, same thing, I'm supposed to teach, this is how you think about forces or whatever, that play can include, and I don't have a good answer, it's a hard thing to do, that it includes, that can include a kind of appropriation that encourages appropriation for one's own purposes. Mm-hmm. And for further use in one's own subversion, like that's one way to engage with the norms, as opposed to these are correct. So they do violence just by existing, but also what everyone is allowed to do with them changes our relationship with them. So that my only point is that I think exactly we're fighting the same. It's easy to say, oh, we can play in computation, but what does that really mean when it comes down to disciplinary norms and more formal education experiences and what that means? So all just to say that I think I have struggled often with the same kind of question.
Yeah, thank you.
Are there any other questions or comments that people have? Well, let's all thank Dr. Sengupta, Dr. Shanahan. Thank you. That was a really wonderful presentation. And I'll remind people the second lecture in this series, Pratim Sengupta with Ariel Ducey and with discussion by Anand Taneja, will be on Thursday from 1 o'clock to 2 o'clock about connecting modeling and the experience of pain and moral horizons. So we'll see you then.
Thank you so much.
Thank you, everyone. Thank you. This was really wonderful.
Thank you so much, everyone. Thank you, Jonathan, for your facilitation and for questions and just being here, everyone.
And Mary Gray, thank you so much for setting this up. Thank you so much for all the labor that actually went into this, and I'm really appreciative of everything.
Yeah.
Of course. I'll see you on Thursday.
Yeah, thank you.